lack of funny hat. So, re-recording. Over to you, Joe, who does not have a very funny hat, and you need to improve for next time.
Yeah. I will do my best. Let's look at the doc on the meeting, which I can't. There it is. So the community call doc is up. It's attached to this meeting. Anyone is welcome to add any agenda items. So we have a couple things that we thought to talk about. But anybody is welcome to add anything they'd like, and we will address them kind of as we get to them. First, a couple of updates. Couple of changes, I guess, since the last community call. Both of these from Daniel. Thanks, Daniel. Apparently the only one doing work on Tempo right now. Added Redis support, which is awesome. We don't use Redis internally, or I think we do for some things. We mainly use memcached, but Redis is, of course, extremely popular and an awesome addition to Tempo. A lot of people like Redis. And then case 6, which is, I believe, where you work. Is that right, Daniel?
Well, yeah, it's where I interned during the summer, and I will join full-time on January. Right now,
Cool.
I'm finishing my studies. Yeah.
Cool, very cool. So I guess they have this benchmarking tool that's really neat. It's where you can do kind of like these benchmark tests in JavaScript. And so we've added those into our CI pipeline to get some kind of idea of changes and how those impact, ingestion and stuff. We hope to expand on those kind of over time. Other than that, we're going to talk a little bit about where things are internally at Grafana. But I want Ananya, who's been working mainly on the query path, to walk through some of those changes and what's going on there. And then Marty's going to talk about Compaction, which he has spent a fair amount of time on. And then we can get back to making fun of my hilarious hat.
Not so funny hat.
Damn it. Are you sure? It's the best I got.
We're pretty sure.
We're pretty sure.
Let's go check the kid's toy chest and see if there's something worse.
So yeah, thanks, Joe. So yeah, I'll talk a little bit about the work on the query path that's been happening. So we started out because the query path has been like fundamentally incomplete. There's not been a way to scale the query path currently. So the way it works right now is a query hits a single querier, and the one single querier needs to do all of the work about fetching the trace. And it's going to be looking up the Bloom filters on every block that's in the backend. So that's like like at Grafana Labs, we have around like 400 blocks in our backend, or like I think that's gone up a bit in this last week. But yeah, so a single querier fetches the Bloom filters for all of these blocks, filters them out, fetches indexes for the ones where it gets a hit, and then finally fetches the object ID. And so this was like a way in which like we were not able to shard this work out or sort of split it up between multiple queriers. So each querier had to do all of the work for a given query. And there was no way, like if we see latency climbing, there's no way we can just up the number of queriers in our deployment and bring it down. And that was bothering us. And so we decided to work on a query frontend, which is very similar in function to Loki and Cortex. It sort of shards up the block space and splits the work between the queriers. So we can actually bring down latency by scaling up the deployment of queriers. And that's been the work that's been happening for the past 2 weeks. And there's like 2 parts to this. So the first PR that's already in is about adding some extra parameters to the querier so it can support the shard work. And so these parameters look like the block boundaries, right? So now we're going to specify the block boundary for each querier. So we're going to say, hey, you should only look between this block range, like this block ID and this other block start and block end IDs. And so that limits the range of search for each querier. And so this PR that adds the support for these boundaries was merged. And the next step is to actually add this querier, the query frontend between Grafana and the queriers. So every query now will first hit the query frontend, which will be responsible for splitting it up. adding all of these parameters and then inserting it into a queue. And then the queryers will sort of feed off of this queue and then work on their set of assigned shards and then return the trace to the query front end. So that PR's like it's almost done. We're going to, I mean, it's in the draft stage in GitHub, and I'm going to like update it soon. But yeah, that's been the work, and hopefully this will like it'll give some more control over latencies to us. Right now, it's all been there's nothing we can do about it, and hopefully we'll have some more control over the latencies. It's let's see what else. It should also help do exhaustive search. So now that we are able to split up the shard space, the block space, we'll have multiple queryers working for the same query, and they can all return results. And if multiple, like if a trace is split between blocks, we can sort of get it in the query front end, combine the trace, and then return it in like a really short time compared to what we would have before. And yeah, that's been the work that's been happening.
Cool.
Any questions or comments on that? Like, cool. Okay, none.
So to be clear, I don't know, I guess we've seen block lists up to 1,000 or so, generally when things are broken. Right now we're in the 600s. We're in a couple, like over 1 billion traces, and our P50 is like at a second. So I don't think that's terrible, but this would definitely give us like some room to improve and actually devote resources to scaling. Another thing I'd like to add for the query path is we intend to drop the requirement of the Jaeger query kind of plugin thing. When we first made all this, Grafana did not have any support for traces, and so that was the only way to see tempo traces was through that Jaeger query and the gRPC plugin. And so we're going to drop I think we're going to leave it. We're going to have it as an option for people who want to use it that way, but we are going to just drop the requirement of it and have Tempo be able to directly return responses to Grafana. There's a ticket out there. There's an issue out there for Tempo, struggles to return 100,000 span plus traces. And we found that it was spending almost all of its time just marshalling and unmarshalling repeatedly to protobuf and JSON and everything under the sun. And so by removing some of this, we're going to remove some of the hops, and it should help with latencies on large traces.
Yeah, we also merged that with the last PR, like content negotiation, and we're marshalling into proto now instead of JSON. So
that's a good thing to add in the updates. Ananya did add basic content negotiation on the query path. So you could, previously it was always returning JSON, which was expensive to marshal. And so we switched to protobuf between the query Jaeger query and the querier. Cool. Marty, you want to talk about compaction a little bit?
Sure.
I'll take some notes.
I can talk about compaction. If it's okay, I actually want to present a couple like little things here. I guess can everyone see it's just 2 little slides. Can everyone see it okay?
Yep.
Cool, yeah. So for compaction, like the main thing that we've been kind of like looking at is performance and observability. Like compaction is a big it's important. It keeps the block list length down. It keeps like search times manageable and polling and things like that. So it's important. Small blocks that are coming out fast out of the ingesters have to be compacted. So kind of like mainly maybe the biggest thing here is we made a change to where it can actually compact up to 8 blocks at one time. So previously it was always taking, only 2 blocks. It was limited. So, rough calculation, like that's 67% less shuffling of like level 0 data, which is like the most active data that comes out. So it can do that early compaction where it's needed the most a lot faster. Other metrics. So, talking about observability, like questions about like compactor performance, like how's it doing? So we've looked at some metrics that made sense to add here. So bytes written, how much data is being flushed to the back end. Objects written, how many objects or traces are being flushed to the back end. things that make sense to calculate rates on, and to do other things. These are also per tenant. Objects combined. So part of the one job of the compactor is like when it's taking blocks together, it doesn't just append the data directly. It actually will, if it finds the same trace across multiple blocks, it will combine those together. And so this is required because actually if you have a replication factor more than one, it's expected that the same data is actually distributed out into a couple different blocks. And so the metric there is just keeping a track of like how often that's occurring, like when it's combining things. So it's related to your replication factor, and then just the number of blocks that are being compacted. There's been some other improvements, just CPU, memory, error handling. So just things that make sense. So some blocks that are, if they're longer, towards the older end of the data, they can take up to an hour maybe to do compaction and things like that. So it's those things can have larger effect maybe. The goals, so I put this in here. We've kind of bandied it around. Kind of like an internal goal is like, what would it look like to scale to 1 million spans per second? So that's not too far away. I guess, Joe, you'll touch on that a little bit later, maybe like in the document, but we expect compaction maybe to be, something that hits, maybe a ceiling, like scalability concerns faster than others maybe, or at least before that limit. So, what are the things that make sense? So just general observability are more things that we need to look at. Maybe defining these questions and answering them, like, are the compactors keeping up with the load? What does it mean for a compactor to even be keeping up? Like, what sort of metrics make sense for us to add to look at things like that? What is compaction's end goal? Like, what is the actual block count size, window size, things that make sense? When is compaction ever done? At some point, it doesn't make sense to compact this data any further, but you could keep compacting. So there has to be some sort of, what is the end goal there? And then, once we can answer those questions, we can provide some better guidance, for a given load, then this number of spans per second, needs this many compactors and things like that. So I think there's definitely some open-ended questions that we need to answer there. Cool.
Yeah. Something else that happened recently was we were seeing some additional load and our block list was growing, and we have this setting called the time window. And so we found that reducing the time window actually helped us keep our block list shorter. This is kind of on the spot, Marty, but something I was thinking about was a time window is kind of a kludge to make it easier to find blocks that go together. So basically a time window is a set of blocks that will even consider compacting. It just made the algorithm much cleaner because it's here's the 10 that you'd even ever look at to compact. Is there an ability to even remove that and instead perhaps have a more organic method of identifying a set of blocks that can be compacted together?
Yeah, so the default is 4 hours, meaning that it will always consider blocks within the same 4-hour time span that can be compacted, right? And this is fixed, like a 4-hour interval fixed off of the Unix epoch, right? So it's a fixed interval. So it makes, the ability for sharding, only one compactor will ever own a given interval. We reduced ours to 1 hour, which means for that hot data coming out of the ingesters, like that 1 hour can be sharded, to 4 compactors instead of 1. So that was able to, increase our utilization, right? Just to kind of explaining what you're talking about. Yeah.
Oh, yeah. We have to keep the time window for sharding.
Well, I have some ideas, but basically, yeah, like, that window is kind of like good and bad. As you reduce it, you increase the sharding of your compactors, like the ability, they can split that workload of data that needs to be compacted better because they own a smaller portion of like the amount of work. However, it means that the window of data that you can consider to compact also gets smaller. So kind of like it's a balancing act. And so, yeah, I think what we need, maybe we need to look at replacing that. Is there something, different that's more dynamic, but it still has to be, with the sharding and things like that. You won't want blocks,
right,
the same block being compacted into 2 more blocks. Like it needs to be compacted once. Yeah.
Right. So we were on 4 hours and we were seeing roughly 4, when the compaction was complete, we were seeing about 4 blocks in each section, each time window of 4 hours because of our upper cap of 6 million traces per block. So what we found was by reducing it to 1 hour, we're roughly matching what our max compaction size was anyway. Compaction was able to keep up much better, and it was due to the right distribution across the compactors. So we should probably put that in some kind of operational guide somewhere. Like, we have a real basic description of some of our settings, but like certainly a guide of some sort. Let me make a note of this. I think Marty, in particular, at this point, yours would be the best for the compactor side, all the tunables and like kind of why you would choose one value over another. So
Right.
one day, perhaps.
Yeah,
You could
there's
do that.
definitely a balancing act. And maybe we should consider changing the default to 1 hour. It's just a nice round number. Maybe it makes sense for most use cases.
It's a good number. It's a very good number.
Started an operational doc. Never found the time to finish it.
Oh yeah, all right. Ananya has a PR app. What is that? Like troubleshooting, and it's a
Yeah,
good
the-
doc. I think I had some comments on it, but getting that to completion would be great for sure.
Yes. Should
Cool. So internally, we're currently seeing 150,000 spans per second, which is disappointing. But for most of this week, and I should track down why this is, but for most of this week, we're actually at 200,000 spans a second, which is part of what had us looking a little bit at the compactor, because we were seeing it growth in the block list, and growth in the block list tends to reduce query latency, or sorry, increase query latency. And so we're just kind of poking around and seeing what was going on there, which is where we found some of those settings that Marty was playing with. But so internally, we've seen about 200,000 spans per second. I'd say sustained, maybe 210 or so, a little bit above that. And we're fine. We're easily at the scale. I think double the scale would be fine. Once we start pushing to 1 million spans a second, I think is when, like Marty said, compactor is going to be an interesting thing, or it's going to be interesting to see how that grows at 1 million spans per second. Ananya's work on the query front end makes me comfortable with the query path once that's in place, well past 1 million spans a second. It's really going to be a matter of wrangling these extremely long block lists. That's going to be the thing that just grows with the number of traces kept and your retention and all these things. So we don't really have, I don't know, I'd say personally, it'd be nice to see 1 million spans per second and what tempo looks like at that scale. I don't know what the goals of the community are. I would be really interested to hear what kind of scale people would like to see, if anyone is willing to share that, or numbers they may have already been seeing internally. If anybody can share perhaps personal experience with tracing or tempo specifically, but the kind of load that you might want to see at maybe some kind of extreme scale, I'd love to kind of target that or understand what people think about when they think of extreme tracing scale.
We have new faces on the call. Do we want to say hi?
Hey, Ken. He's not new. He works on Cortex all the time, right? You're part of Cortex. Yeah. Okay.
It's the first time on the call. But yes, I'm one of the maintainers for Cortex.
Right.
And I would normally join the Loki one too, but the Loki community call is at like 3 o'clock in the morning for me. So I appreciate having this one at a more reasonable time.
Are you based on the West Coast?
Yep. Yeah.
Oh, okay. Yeah, this is definitely more reasonable for you then.
Yeah,
Whatever.
I've only just started tinkering around with tempo myself. I've got it installed locally, but it doesn't support Azure Blob Storage. So
yeah, it doesn't, does it?
I can't deploy it on my AKS clusters yet.
Right. Yell at Gotham. He told us, he swore to us he'd have this in place.
Yeah.
Oh,
Azure,
I'll go talk to him,
yeah, it's definitely on the list.
I've got the issue up. I just liked it.
Yeah.
I actually started implementing a possible solution to this last night. So if I'll reach out to Gautam and see where he's at, but if not, I'll.
He's not made any progress.
Okay. Fair enough.
I mean, he may have, but if he has, he's not sharing it with us.
All right. I think I almost have something testable. So once I try it out, I'll probably submit a PR.
Oh, that would be awesome. Cool. For sure. Very cool. You don't happen to have any thoughts on extreme tracing scale?
I do, but I don't think they're feasible for tempo right now. What we've got at AKS is obviously probably on the very extreme end for distributed tracing. But I usually a million a second is usually a good first measure, right? Like get that working there.
Good first measure. All right. I think a million a second is, I don't see that being as a problem. There'll be some growing pains, but there won't be like major things that will fall apart. There won't be like re-architecture required to hit a million spans a second.
Yeah, the compactor is the piece that I'm really interested in, just from the challenges we've had with the compactor and Cortex as we get to larger and larger block sizes.
Right.
Yeah, we should clarify. Yeah,
Go
I
ahead.
think that million is kind of probably for a single tenant. I think like once you add multi-tenancy and like it's already sharded a layer above that. I
Yeah.
think, yeah,
Right.
Yeah, a million across like a bunch of tenants, I think is a much easier problem than one
Yeah.
tenant being that giant silo, and that's the problem. Like I'm facing with at Microsoft with some of our stuff. We have a very wide base of people internally that are using some of these techs, but we also have people who are extremely large silo, like single tenants that would challenge some of these systems.
Mm-hmm. Yeah, our compaction challenges are slightly different than Cortex. I think we have more data, but way less processing. I think they're more CPU bound, and we are more just like throughput to the back end bound.
Okay.
In GCS, we see about 40 megasecond off the back end, 40 to 50 from our compactors. And so I think that is kind of roughly our cap. Like we're going to find that to be ultimately what the thing we cannot overcome when we're trying to compact some huge amounts of data.
Well, yeah, I'm looking forward to getting this. Once I get the blob storage to work, I will look forward to trying this on AKS.
Yeah, no doubt. Keep us updated in that issue because we were just recently discussing some changes to the backend interface that would actually make it a lot easier. We want to simplify that interface to be dumber and to be more like a file I/O style interface where it just supports like read or read range, some basic things instead of the full. I think right now you can like ask for individual object types like read index or read block meta or some crap.
Okay.
I should know. I wrote it. But right, me and Marty and Ananya were just discussing that because we wanted to do some changes internally, and I think making that dumber, which would make it easier to add Azure Blob Storage and other backends, is on the list to do.
All right. Yeah, I'll keep you updated how I get going on that.
Okay. Very cool. Cool.
FYI, I'm already looking at moving the local call to a later time.
Thank you, Richie.
It's really a balance of.
Oh, I know it's
people like poor Ananya. What is it like 10 o'clock up there, Ananya?
It's 10:30.
Yeah.
10:30. Okay.
Yeah,
Your weird half-hour time schedule.
Yeah, we have just in my immediate group here at work, we have that challenge because we're globally distributed. So we almost every one of these sorts of calls we have that's group wide, we have to have like 2 or 3 different times to hold it at and rotate them through.
Right, no doubt.
Yeah.
I think you broke up a second there, Ananya.
Yeah, I think like my network's really bad. Go ahead.
Okay, sure. Cool. Does anybody have anything else you want to address or talk about? Excited for Daniel getting his job at K6 come January. I don't know what ability you'll still have to contribute, but certainly thank you for everything you've done, and any participation you can still do would be cool.
Yeah, sure. Actually, I will work on observability. I worked on metrics stuff during the summer, and I hope to work on tracing too. So,
Very cool. Awesome. And then Ken, thanks for joining, man.
Cool.
It's good to see you, bud.
Yeah, no, thank you. It's good to. I got the invite, and it's we'll see how it goes. Yeah, cool. I was excited. I was surprised and excited to see Temple get released. So.
Me too.
Surprised? What's that?
There was some questionable period over the summer where Tempo's future was up in the air a bit, but we're back.
Yep. Cool. I've had a good experience with Loki, so I'm hopefully going to trend that into Tempo as well.
Awesome. All right. Well, everybody take care, I guess. We can end a little early here, and I'm going to go eat some lunch, and then you go to bed.
Have a great evening and good day, everybody.
Yep. See y'all.
Bye.
See you.